The last time this rock came as close to Earth as it is tonight, the year was somewhere around 1622. No one watching this had been born. Their grandparents had not been born. And it will not return this close until the year 2133, long after we are all gone. Tonight, for the only time in your life, a kilometer-wide planet killer is gliding past your window, close enough to see in a backyard telescope. But the real story is not the rock. It is the dish in the California desert that has locked onto it, and the unsettling reason it is watching something that cannot hit us. Stay with me, and I will show you what they are really looking for. If watching a planet killer slide past in real time grips you, subscribe so you never miss the next close call. Comment whether you will be out tonight hunting for it near Antares. Now, let's get into it. Right now, while you are watching this, a mountain is flying past the Earth, not a metaphor, not a figure of speech. A solid body of rock and metal, somewhere close to 900 meters across, is sweeping through the dark just beyond the orbit of the moon, and at this very moment, it is closer to us than it has been in roughly 400 years. The last time this particular object came this near, no one alive today had been born. No one's grandparents had been born. The year was somewhere around 1622, and it will not come this close again until the year 2133, long after everyone watching this is gone. Its name is 1997 NC1. In the catalogs, it carries a number 2, Asteroid 152637. But the name is the part that matters, because that name has been sitting quietly in a database for almost 30 years, waiting for tonight. And tonight it arrives. At its closest, it passes about 2.56 million kilometers from Earth. That sounds enormous, and in human terms it is. But in the language of the solar system, it is a whisper away. It is only about 6.5 times the distance from here to the moon. For an object this large, that is extraordinarily, unusually close. Now, let me say the most important thing first, before your stomach drops, because I know how a video like this can feel. There is no danger. None. This rock is not going to hit the Earth tonight, or tomorrow, or at any point in the next 100 years that anyone can calculate. You can sleep tonight. Your children can sleep tonight. This is a near miss only in the way that 2 cars passing on a wide highway are a near miss, which is to say, not really a miss at all, just 2 things moving past each other in a very big space. And yet, I would not be making this video if that were the whole story, and you would not still be watching. Because here's the thing that should make the hair on your arms stand up, just a little. If this object is harmless, if it is passing us by millions of kilometers with no chance of impact, then why, over this exact weekend, is the most powerful radar humanity has ever built locked onto it, tracking it hour after hour like a hunter watching something move through the trees? That is the question this whole video is built around. Hold on to it, because the answer is not what the conspiracy corners of the internet think it is, and it is not the comfortable answer the cheerful headlines give you either. The truth sits in a strange middle place, and by the time we get there, you are going to understand something about your own planet that most people walking around today simply do not know. If you have been with this channel for a while, you already know this object. You know it because we counted down to this exact night. A few weeks ago, we marked the calendar. We talked about a kilometer-class rock on a 22-day approach, and a lot of you left comments saying you would be watching the sky when it arrived. Well, here we are. The countdown hit 0. The night we were pointing at is the night you are living in right now. But the thing about a countdown is that when it ends, the story does not end with it. It changes. Because in the days since we last spoke about this object, something new happened. The dish in the desert started listening, and what it is hearing is rewriting, in real time, what we thought this thing even looked like. To understand why any of this matters, you have to understand what is actually out there tonight, drifting past your window. You have to understand what 1997 NC1 really is, where it came from, and why an object you cannot even see with your naked eye has the world's planetary defense community quietly, intensely paying attention. So let us start there. Let us start with the visitor itself, because once you understand what it is made of and where it lives, the question of why we are watching it stops being a conspiracy and starts being something far more interesting, and honestly, far more unsettling. Let me introduce you to this thing properly, because it deserves a proper introduction. 1997. NC1 belongs to a family of asteroids called the Atens, and the Atens are a particular kind of neighbor, the kind you should know a little about. Most of the asteroids people picture live far away, out in the main belt between Mars and Jupiter, minding their own business. The Atens do not. The Atens live close. Their orbits are tucked in tight around the Sun, spending most of their time inside the orbit of the Earth, closer to the fire than we are. This particular one loops around the Sun in only about 10 months, on a path tilted by roughly 17 degrees to our own, swinging out just far enough on each pass to cross the line where Earth travels. That crossing is the whole point. That is what makes it one of ours to watch. It was found on the 5th of July, 1997, by a survey program designed to do exactly one thing: to hunt for the rocks that come near us. For almost 30 years since that night, telescopes have tracked it, measured it, refined its path, again and again, until its orbit is known with a precision that is honestly hard to wrap your head around. That is why we could tell you, weeks ago, not just the day it would arrive, but the hour, almost to the minute. We knew it would reach its closest point near 11 in the morning, Universal Time, today. We knew this the way you know the train schedule, because the math is that good. Remember that fact. It is going to matter later, when we talk about the people who insist the numbers are being hidden from you. Sit with that for a moment, because the precision is genuinely strange when you stop to think about it. We are talking about a dark, charcoal-colored rock, smaller than a city, moving through black space hundreds of millions of kilometers away. And we can say where it will be on a given morning, 3 decades in advance. How is that even possible? It comes down to patience and geometry. Every time the asteroid has swung close enough to photograph over the past 29 years, astronomers have measured its exact position against the fixed background of stars. Each measurement is a single dot on a graph. String enough dots together, across enough years, and the orbit they trace becomes a line you can extend in both directions, into the past and into the future, with shrinking uncertainty. The survey that first caught it was built for precisely this purpose: to sweep the sky night after night, looking for the faint, moving points of light that betray a near-Earth object against the still stars behind them. It found this one and handed it to a global machine of follow-up that has refined its path ever since. And the fact that it is an Aten, a rock that lives most of its life closer to the sun than we do, is part of what makes it worth watching so carefully. An object out in the main belt keeps a respectful distance. An Aten does not. It is an inner system creature, riding a tight, fast loop that repeatedly carries it across the lane the Earth travels in. Most of the time, when it makes that crossing, the Earth is somewhere else entirely, on the far side of its own orbit, and the two never come near. But the geometry is not random forever. Every so often, the timing lines up, and the crossing happens when we are close by. Tonight is one of those alignments. The orbits did not change. The clockwork simply brought the two hands of the clock to the same number at the same moment, the way it does for this object, about once every few years, and at this extreme closeness, only once in 4 centuries. Now, the size. This is where the title of this video earns its keep, and where I have to be honest with you, because honesty is the entire job here. You will see this object described in some places as a planet killer. You will see it compared to the length of 5 cruise ships lined up end to end, or to a tower several times taller than the tallest skyscraper on Earth. All of that is roughly true. Its best estimated diameter is around 900 meters, though the real figure could fall anywhere between about 450 meters and 1,800 meters, depending on how dark or how reflective its surface turns out to be. In round numbers, it is a kilometer-class object, a body close to a kilometer wide. And here's the honest part. A kilometer is a very specific, very meaningful number in this field. It is not a random size. Scientists who study impacts draw a line right around there, and they call it the global catastrophe threshold. Below that line, an impact is a regional disaster. Terrible, deadly, but local. At or above that line, something changes. An object this big does not just destroy a city or a coastline. It has the potential to reach up and touch the entire planet's climate all at once. So when someone calls this a planet killer, they are not completely wrong. But they are not quite right either. And the difference between those two things is the difference between fear and understanding. Here is the precise truth. An object like 1997 NC1 would not kill the planet. The Earth would be entirely fine. The Earth has been hit by far worse and spun on without missing a beat. What an object this size threatens is not the planet. It is us. It is the thin, fragile film of civilization stretched across the planet's surface. The rock is a threat to the farms, the power grids, the supply chains, the delicate web of systems that keep 8 billion people fed and warm and alive. That is what sits in the balance with a kilometer-class impact. Not the world we built. Keep that distinction close, because we are going to come back to it. And when we do, you will see why the people who measure these things for a living do not sleep quite as soundly as the headlines suggest. So that is what is passing us tonight. A kilometer-wide Aten, known for nearly 30 years, sitting right at the edge of the size that matters most. Which brings us to the next question, the one you are probably already asking. If we have known about this thing for decades, and we know it is missing us, then what exactly makes tonight so special? Why this night, and not any of the thousands of nights before it? The answer is a single word, and that word is close. Distance in space is everything. It is the difference between a catastrophe and a curiosity, between a headline and a footnote. And what makes tonight remarkable is not that 1997 NC1 exists, or even that it is near. It is how near for something this large, and how rarely that combination happens. Let me put it in perspective, because perspective is the only way to feel this. Small rocks pass close to Earth all the time. Truly, all the time. Car-sized and house-sized objects slip between us and the moon on a regular basis, and most of the time you never hear a word about it, because if one of them hit, it would burn up in the sky as a bright fireball and rain down a few harmless pebbles. We have talked about those on this channel before. The fireballs that tore across the sky over a dozen states. The little house-sized visitors that skimmed past closer than the moon. Those are common. Those are the background hum of living on a planet inside a shooting gallery. But a kilometer-class object coming this close is a different animal entirely. That is not a regular event. That is, statistically, something that happens only about once a decade. To find the last time a rock of this size came this near, you have to go back to January of 2022, to an object called 1994 PC1. That one was also about a kilometer across, and it passed at a little under 2 million kilometers, roughly 5 times the distance to the moon. A lot of people remember it, because for a few nights, amateur astronomers all over the world pointed their telescopes up and watched a faint star that was not a star at all, but a mountain sliding through the constellations. Tonight is the sequel to that night. Tonight is the next time the dice came up this way. To really feel how uncommon this is, you have to separate two things that sound similar, but are not. Close passes are common. Close passes by something this big are not. Every week, objects drift past us inside the distance of the moon, and almost all of them are small, the size of a bus or a building. The kind of thing that would make a spectacular fireball, but leave the world unscathed. Those are the small siblings we have followed on this channel before. The bright streaks that crossed a dozen states in a single night. The quiet little rocks that slipped between us and the moon while almost no one looked up. They are the ordinary traffic of a planet sitting inside a debris field left over from the building of the solar system. As you go up in size, though, the objects become dramatically rarer, and a close approach by one of them becomes a genuine event. There are only so many kilometer-class rocks on Earth-crossing paths, a few thousand at most, and we have found and mapped nearly all of them. So when one of those few thousand threads close to us, it is not background noise. It is a marked date on the calendar of everyone who studies these things, circled weeks or months in advance. And there is something almost humbling in the timing itself. This object has been on this orbit, making this loop for far longer than human beings have existed. It was crossing Earth's path when there were no telescopes, no astronomers, no one at all to mark its passing. The last time it came this close, in the early 1600s, anyone who looked up and happened to catch a faint moving point of light would have had no idea what they were seeing. No way to know it was a mountain of rock and not a wandering star. We are the first generation in the entire history of this object that can look up, understand exactly what it is, and know precisely when it will return. And for 1997 NC1 specifically, tonight is the closest it has come in about 400 years. Think about what was happening on Earth the last time this rock was this close. It was around the year 1622. And after tonight, it will recede back into the dark and not return at anything like this distance until the year 2133. So this is, in a very literal sense, the only time you will ever get to see it like this. Not the only time this century, the only time in your life. And you can see it. That is the quietly magical part. You do not need a space agency or a mountaintop observatory. As it makes its closest pass, this object brightens to about 10th magnitude, which means a backyard telescope, something with a 6-inch mirror, is enough to catch it. It is moving through the constellation Ophiuchus, the Serpent Bearer, sliding not far from one of the most remarkable stars in the entire sky, the dark red supergiant Antares, the brooding red jewel of the Scorpion. If you have a telescope and clear skies tonight, you can find that patch of sky, and you can watch. And here is what makes it worth the effort. Because this object is both close and fast, moving at something like 9 kilometers every second relative to us. It does not just sit there like a planet. At its closest, it drifts. You can actually watch it move against the background stars in real time over the course of just a few minutes. Most things in the night sky are frozen. They wheel overhead so slowly that you would need hours to notice. But this, tonight, you can sit at the eyepiece and watch a point of light crawl past a star, and know, in your gut, that you are watching a kilometer of rockfall through space at thousands of meters per second. There are very few moments in amateur astronomy that give you that feeling, that visceral sense of motion, of something real and massive actually moving. Tonight is one of them. Now, I want to head off one thing, because I know this channel, and I know some of you are already thinking it. That pairing in the sky, The asteroid sliding past the blood-red star Antares. It looks like an omen. It looks like the universe is trying to tell us something. A dark rock crossing the red jewel of the Scorpion on the very night it comes closest in 4 centuries. I understand the pull of that. But let me be straight with you. It is a trick of perspective, nothing more. The asteroid is a couple of million kilometers away. Antares is about 550 light-years away. The two are not near each other in any real sense at all. One is practically in our backyard, and the other is so far away that the light you see left it before the telescope was even invented. They only appear to touch because they happen to fall along the same line of sight, the way your thumb can blot out the moon. It is beautiful. Photograph it. But it is not a message. The real story is not written in the stars behind the asteroid. It is being written, right now, by a dish in the California desert that has turned to face this thing and started to listen. And what it is hearing is where this gets strange. In the Mojave Desert in California, there is an antenna so large it could swallow a baseball field. It is part of a system called the Goldstone Solar System radar, and it is one of only a small handful of instruments on Earth capable of doing what it is doing this weekend. The way it works is almost unnervingly simple to describe and almost impossible to actually pull off. The dish points at the asteroid. It fires a beam of radio waves across millions of kilometers of empty space. Waves powerful and tightly focused, aimed at a moving target smaller than a town. Those waves strike the rock. A faint reflection bounces back. And another antenna, listening, catches that reflection as it returns, many seconds later after its round trip across the void. That is it. That is the whole trick. You shout into the dark, and you listen to what comes back. But buried inside that returning whisper is an astonishing amount of information. By measuring exactly how long the reflection took to return, scientists pin down the asteroid's distance with astonishing accuracy. By measuring how that returned signal is smeared and stretched across different frequencies, they can read the object's spin, map the roughness of its surface, and slowly, ping by ping, reconstruct its actual three-dimensional shape, almost like a photograph assembled out of sound. For an object we have only ever seen as a single dot of light, radar is the closest thing we have to flying a spacecraft out to meet it. So this weekend, that is what is happening. And here is the first piece of genuinely new information, the thing that did not exist when we counted down to this night a few weeks ago. As the radar has started to resolve the shape of 1997 NC1, the early picture coming back is not a simple round potato of a rock. The preliminary read suggests something more interesting, an elongated body, possibly 2 distinct lobes joined together, what astronomers call a bifurcated shape. If that holds up, and I want to be careful here, because this is a preliminary result, and the analysis is still being refined as I speak, then this object may be what is called a contact binary. 2 separate chunks of rock that, long ago, drifted together so gently that instead of shattering, they simply touched and stuck, and have been traveling the solar system locked together ever since, like 2 boulders frozen mid-handshake. A peanut a kilometer long, tumbling through space. And if that picture holds, it places 1997 NC1 in surprisingly familiar company. Radar has caught a number of near-Earth asteroids wearing this same strange shape. 2 lobes married at a narrow neck, and every time it teaches us something about how these objects are built. The leading explanation is gentle almost to the point of being tender. 2 separate bodies, traveling in the same neighborhood, slowly lose energy and drift toward each other over enormous spans of time, until at last they meet at walking speed and simply come to rest against one another, held together by nothing more than their own feeble gravity. No crash, no fusion. Just 2 rocks leaning on each other for the rest of time. It means many of these objects are not solid at all. They are rubble, loosely bound piles held together by a grip so weak that in places you could pull them apart with your hands. That sounds like a curiosity, but it is one of the most important facts in all of planetary defense, and it loops straight back to the question we keep circling. If an object like this were ever on a collision course, its structure would decide everything about how we might stop it. You cannot shove a loose pile of rubble the way you would shove a solid boulder. Hit it too hard, and instead of nudging it aside, you might shatter it into a shotgun blast of smaller pieces, each one still on roughly the same path, turning one tracked threat into a dozen untracked ones. This is exactly the kind of thing the people in the desert need to know long before the day they actually need to act on it. And the only way to learn it, short of flying out to meet the thing, is to do what they are doing tonight, reading the body's shape and structure out of the returning radio while it drifts safely past. That detail alone is worth the price of admission, because it tells you these objects are not solid cannonballs. Many of them are loosely bound, lumpy, structurally complicated things. And that matters enormously for the question we keep circling, the question of what we would do if one of them were ever actually coming for us. But before we get there, we have to answer the question this whole video hangs on. Why pour this much effort, this much of the world's most precious radar time, into a rock that everyone agrees is going to miss us? The answer has 3 layers, and all 3 are real. The first is the orbit. Even though we have tracked this thing for almost 30 years, radar refines its path far beyond what ordinary telescopes can manage. Optical telescopes tell you where the asteroid appears on the sky. Radar tells you where it actually is, in 3 dimensions, and how fast, with a precision nothing else can match. And that precision feeds forward through time. With it, the people who model these orbits can project this rock's path, not just for the next century, but for the centuries beyond, and check it against something genuinely worth worrying about. Something called a keyhole. Let me explain a keyhole, because it is one of the most important and least understood ideas in all of planetary defense. When an asteroid passes the Earth, our gravity tugs on it and bends its path slightly. Most of the time, that bend is harmless. But there are tiny regions in space, narrow as the eye of a needle, where if the asteroid passes through that exact spot, Earth's gravity nudges its orbit by just the right amount to set up a collision on some future pass, years or decades or a century later. Thread that needle, and a harmless flyby today quietly becomes an impact in the distant future. The only way to know whether an object will ever encounter one of those keyholes is to know its orbit with extreme precision. And the only way to get that precision is radar, during a close pass, exactly like the one happening tonight. There's a third layer too, and it is subtle. Sunlight. It sounds absurd, but light itself pushes on these rocks. As an asteroid absorbs sunlight on one side and radiates that heat back into space on the other, it feels a tiny, continuous push, a force named the Yarkovsky effect. It is unimaginably gentle, but over centuries, acting constantly, it can shift an asteroid's orbit by a meaningful amount, the difference between a clean miss and a keyhole hundreds of years from now. To predict that drift, you need to know the object's shape and spin and surface, which is precisely what this weekend's radar is measuring. Do you see how it all connects? The shape we are mapping tonight is not trivia. It is an input into a calculation about whether this rock could ever, in some far-off century, become a problem. So no, they are not watching it because they are hiding something. They are watching it because this is the single best chance in 400 years to learn everything there is to know about a genuine, kilometer-class, civilization-scale object, while it poses no threat at all. It is a free dress rehearsal. And the reason a dress rehearsal matters so much is that the real performance, if it ever comes, would be unlike anything in human history. To understand why these scientists treat a harmless rock with such deadly seriousness, You have to understand exactly what would happen if a rock like this one were not waving as it passed, but falling. So let us go there. Let us, just for a few minutes, imagine the thing that is not going to happen. Imagine 1997 NC1 were not missing us by 2.5 million kilometers. Imagine it were on the line. What does a kilometer of rock, moving at tens of thousands of kilometers an hour, actually do to a planet? The first thing to understand is that almost nothing stops it. An object this size does not burn up in the atmosphere the way a little fireball does. It punches through the entire depth of the air in a couple of seconds, as if the atmosphere were not even there. It strikes the surface still carrying nearly all of its cosmic speed, and in that instant, all of that motion has to go somewhere. It converts, almost instantly, into an explosion that dwarfs the entire combined nuclear arsenal of the human species. The impact carves a crater perhaps 10 kilometers across in seconds. Anything within a huge radius is simply gone, erased by the blast and the heat. If it hit the ocean, it would hurl walls of water outward in tsunamis on a scale that has no modern parallel. But, and this is the part that people miss, the crater is not what kills the world. The blast, the fireball, the immediate destruction, as horrifying as it is, stays relatively regional. Terrible beyond words for the people in its path, but regional. The thing that turns a local catastrophe into a global one is what comes after, and it comes for everyone. When an object that large strikes, it does not just dig a hole. It throws a staggering quantity of pulverized rock and dust high into the atmosphere, far above the weather, into the upper layers where nothing washes it out. There, it spreads. It wraps around the planet on the high altitude winds, and it forms a veil. And that veil does something simple and lethal. It dims the sun. For months, possibly for years. Scientists have a name for it, and the name tells you everything. They call it an asteroid winter. Picture what that means. The sky goes gray, everywhere, all at once. Temperatures drop across the entire globe, and the plants, the crops, the green engine that feeds 8 billion people begin to fail in the dimmed light and the cold. This is the real weapon hidden inside a kilometer-class impact, not the explosion, the starvation that follows it. Studies of this exact scenario reach a chilling conclusion. In a strike like this, only a small fraction of the deaths would come from the impact itself, the blast and the heat and the waves. The great majority of the dying would come later, slower, quieter, from crop failure, from famine, from the unraveling of the systems that hold a global civilization together, from people without food turning on each other in the dark. That is why the line sits right around 1 kilometer. That is the global catastrophe threshold. It is the size at which a rock stops being able to destroy a region and starts being able to destroy a civilization. And notice where it would most likely strike, because the Earth's surface is mostly water, which means the probable target for any impact is the ocean, and that changes the shape of the disaster without softening it at all. A kilometer-class object hitting the open sea would not be cushioned by the water. It would detonate on contact and hurl a ring of waves outward, tsunamis on a scale the modern world has never recorded, racing across entire ocean basins to drown coastlines thousands of kilometers from the point of impact. The great coastal cities of the world, where so much of humanity now lives, sit directly in the path of that kind of event. So whether it struck land or sea, the reach would be planetary. There is no safe corner to absorb a blow like that, only the difference between dying in the first hours and dying in the long, dim months that follow. This is why scientists who model these scenarios use a phrase that sounds almost clinical for something so terrible. They call an impact like this a threat multiplier, an event whose direct destruction, however horrific, is only the opening act. The famine, the collapse of trade, the failure of the systems that move food and medicine and order around the planet. That is the main event, and it would fall on people who lived nowhere near the crater, who never saw a flash or felt the ground move, who simply woke one morning into a colder, darker, hungrier world and never found their way back out of it. The studies are blunt about the arithmetic. The overwhelming majority of the dead in a strike like this would be people for whom the asteroid was never anything more than a line in the news, right up until the lights of civilization began, one by one, to go out. To put 1997 NC1 on the map of these things, it helps to look on either side of it. Below it, you have events like Tunguska in 1908, when an object only tens of meters across exploded over Siberia and flattened a forest the size of a major city, and that was from a rock perhaps 20 or 30 times smaller than the one passing us tonight. Above it, far above it, you have the one everyone knows, the Chicxulub impactor, the 10-kilometer monster that ended the age of the dinosaurs 66 million years ago. Tonight's visitor sits in between, but it sits much closer to the dangerous side of that scale than to the harmless one. It is not a dinosaur killer. The dinosaurs faced something 10 times wider and many hundreds of times more massive, but it does not need to be a dinosaur killer to end the world as we know it. It only needs to be what it is. And how often does something this size actually hit? On average, an object around a kilometer across strikes the Earth roughly once every 500,000 years. That sounds comfortingly rare, and in a human lifetime, it is. But the universe does not deal in fairness or schedules. Once every 500,000 years does not mean we are safe for the next 500,000. It means the dice are rolled constantly, and the number could come up tonight, or in 1,000 years, or never in our species' entire future. Which is exactly why the people in the desert are not relaxing, just because this one is a miss. The miss is the lucky part. The watching is the part that might, one day, actually save us. And that, finally, brings us back to the suspicion that started this whole thing. Because if all of this is true, if it is really this serious, then a certain kind of mind starts to ask a darker question. What if they know more than they are telling us? I want to take that question seriously, because you deserve that, and because the instinct behind it is not stupid. It is human. When you learn that the most powerful radar on Earth is locked onto a rock that is supposedly harmless, some part of your brain says, wait, if it is nothing, why all the attention? That is a reasonable thing to feel. So let us walk through it, lane by lane, the way we always do here. Let us take the suspicions out, look at them honestly in the light, and see which ones survive. The biggest one, the one underneath all the others, goes like this. They are pointing the radar at it because they know something is wrong. They have found an impact risk, and the radar campaign is the quiet scramble to confirm it before they decide whether to tell us. It is a genuinely frightening idea, and it falls apart the moment you understand how this actually works. The data from these radar observations is not locked in a vault. It flows out in the open through publicly accessible databases run by the people doing the work. The orbit, the measurements, the refined trajectory, anyone with the patience to look can find it. If they were trying to hide a coming impact, aiming a famous, openly scheduled radar campaign at it, and publishing the results would be the single worst way to do it. The watching is not the cover-up. The watching is the opposite of a cover-up. It is the part where we rule the danger out, in public, with math anyone can check. They are not radaring it because they are afraid of it. They are radaring it because it is the best opportunity in 4 centuries, and they would be failing at their jobs if they let it pass unstudied. The second suspicion. A planet killer is skimming the Earth, and the media is deliberately keeping it quiet so people do not panic. The problem with this one is simply that it is not happening. This flyby has been reported by the American Space Agency, by the European Space Agency, by major outlets all over the world. Nobody is hiding it. What is true, and what bothers people, is that the coverage often feels too calm, too reassuring, like someone patting you on the head. But that is not suppression. That is just the gap between a headline written to soothe and a reality that is genuinely more serious than the headline lets on. The honest middle, the one we have been standing in this whole video, is that this object is harmless tonight and would be civilization threatening if it ever weren't. And both of those things are true at the same time. The phrase planet killer is hype. The underlying danger of the size class is not. You are allowed to hold both. The third lane. The numbers keep changing. The size, the distance. So they must be covering something up. We already dismantled this one without meaning to, back at the beginning. Remember how we knew the arrival time weeks in advance? Down to the hour? That is because the orbit has been nailed down over almost 30 years of tracking. The thing that does shift is the estimated size, that range from roughly 450 meters to 1,800 meters. But that is not someone fudging the numbers. That is the honest difficulty of measuring how big a dark rock is from how much sunlight it reflects, millions of kilometers away. And it is exactly the uncertainty that tonight's radar is built to shrink. The changing number is not a lie. It is science narrowing in on the truth in real time. Then there is the big atmospheric one. Close calls like this are happening more and more often. Something out there is stirring up the asteroids, steering them toward us. I understand why it feels that way. It feels like the near misses are piling up. But the increase is in our eyes, not in the sky. A generation ago, most of these objects would have sailed past completely unseen because we simply did not have the telescopes to catch them. Today, a network of automated survey telescopes sweeps the sky every single night, and they catch things we used to miss entirely. We are not being visited more. We are finally seeing what was always there. And as for something steering them, the only real force that nudges these rocks, beyond plain gravity, is that whisper-soft push of sunlight we talked about, the Archivist effect, and it is gentle and slow and completely understood. Nothing is aiming them. There is no hand on the wheel. And finally, the one this channel has retired more times than I can count, but it always comes back, so we will say it one more time. Some will tell you this is all connected to HARP, to some secret facility with the power to move the heavens. And the answer is the same as it has always been, a matter of simple arithmetic. The energy it would take to perturb a kilometer-wide asteroid millions of kilometers away is greater than anything humanity can produce by a margin so enormous it is almost funny. HARP heats a small patch of the air high above Alaska. It does not, it cannot, reach across interplanetary space and tug on a mountain. The scale is not even in the same universe as the claim. There is one more pattern worth naming, because it sits underneath several of these suspicions at once. It is the feeling that if something this important is being neglected or downplayed, then someone must be doing the neglecting on purpose. But there is a difference, an enormous one, between suppression and simple structural neglect. And almost everything that looks like a cover-up in this field turns out to be the second thing. The reason planetary defense feels underfunded and under-discussed is not that a shadowy office is hushing it up. It is that, until something is actively falling on us, the threat is easy for institutions to push down the priority list, year after year, budget after budget. The information is public. The risk is acknowledged in the open. It is just chronically under-resourced, the way slow-moving, low-probability, high-consequence problems always are. That is not a conspiracy. It is something more ordinary, and honestly more frustrating. It is human nature scaled up to the size of governments. And as for the omens, the sense that a dark rock crossing the red of Antares on this of all nights must mean something. I will only say this. People have looked up at the sky in fear for as long as there have been people, and we have always reached for meaning in the movements of distant lights, because meaning is comforting, even when the meaning is dread. But the universe is not sending us a message tonight. It is doing what it has always done, indifferently, mechanically, on a clockwork far older than we are. The rock is not an omen. It is a fact. And a fact, faced honestly, is far more useful than an omen, because a fact you can measure and track and prepare for. An omen only asks you to be afraid. So when you strip it all away, here is what is left. The suspicion that they are hiding something dissolves, and underneath it is something that is, in its own way, more unsettling than any cover-up. They are not hiding it. It is all right there, in the open. The radar, the numbers, the risk, the plan. And the reason that is more unsettling is that it means the thin margin we live on is not a secret being kept from you. It is a fact being published, in plain sight, that almost nobody bothers to look at. Which brings us, at last, to the real fear. Not this rock, the next one. Here is the truth that the whole night has been building toward. 1997. NC1 is not the scary one. It is the comforting one. Let that sink in, because it inverts everything the title made you feel. This object, this kilometer-wide planet killer sliding past your window tonight, represents the absolute best-case version of the threat. We found it almost 30 years ago. We tracked it. We predicted this pass to the hour. We aimed our finest instruments at it and read its shape out of a whisper of returning radio. From the moment it mattered, we have had our eyes wide open. If every dangerous object in the solar system were like this one, you could sleep easy for the rest of your life. The fear, the real fear, the one the people in the desert actually carry home with them, is everything that is not like this one. Because here is the uncomfortable arithmetic of planetary defense. For the truly enormous objects, the kilometer-class and larger, the civilization enders, we have done well. Surveys have now found the overwhelming majority of them, something like 9 in 10, and none of the ones we have found are on a collision course. That is the good news, and it is real. But as the objects get smaller, our knowledge falls off a cliff. The 100-meter class objects, still large enough to erase a city or devastate a region, we have cataloged only a fraction of them. Below that, the smaller ones, we have barely scratched the surface. There are tens of thousands of objects out there, each capable of leveling a metropolitan area, that we have simply never seen. And there is a blind spot worse than all the rest, one we have talked about before on this channel, and it deserves repeating tonight of all nights. We cannot see the things that come at us from the direction of the sun. Our telescopes look out into the dark to find these objects by reflected light. But an asteroid approaching out of the glare of the sun is invisible to us, hidden in the daylight, lost in the brightness, until it is almost on top of us. The most famous near-miss event in recent memory, the one that exploded over a Russian city and injured over 1,000 people, came in exactly that way, out of the morning sun, completely unseen until the flash. We did not have a single second of warning. That is the gap. That is what keeps the people who do this for a living up at night. And underneath even that lies the deepest problem of all. The one 1997 NC1 quietly forces us to confront. Suppose we did see one coming. Suppose tomorrow we found a kilometer-class object, shaped maybe like the two-lobed rock we are studying tonight, and it was not waving as it passed. It was falling. Could we stop it? The honest answer is that we are far, far better at seeing than we are at stopping. We have taken the very first experimental steps toward learning how to nudge an asteroid off course. The very first. We are not ready. Not for something this size, not on a short timeline. The detection has raced ahead. The deflection has barely begun. And that gap between knowing and doing is the most dangerous place our civilization currently stands in relation to the sky. Here is the part that should stay with you after the video ends. The thing that makes that gap so dangerous is time. If we found a kilometer-class object on a collision course tomorrow, the one tool we have even begun to test, gently nudging an asteroid by running a spacecraft into it, only works if you have years, maybe decades, of warning. A small push applied far enough in advance grows, over the length of an orbit, into a clean miss. But that same push applied too late does nothing at all, which means our survival in that scenario would depend entirely on having seen the thing coming long, long before it arrived. Detection is not just half the problem. Detection is what buys the time that makes the other half even possible. And that is the quiet, unglamorous reason a dish in the desert spends a weekend measuring a rock that will not threaten anyone for 100 years. Every measurement is time, banked in advance, against a day we all hope never comes. So tonight, when this mountain glides past us at its closest in 400 years, and somewhere a tired scientist watches the signals come back from the desert, and maybe you stand in your own backyard and find that faint moving point of light near the red jewel of the scorpion, I want you to hold two feelings at the same time. The first is wonder, because this is genuinely beautiful, a relic from the birth of the solar system, older than every living thing, paying us a visit close enough to see. And the second is a kind of clear-eyed humility, because this one we saw coming. This one we understood. This one we get to simply marvel at and wave goodbye to as it heads back out into the dark for the next 107 years. The real question was never whether 1997 NC1 would hit us. We knew the answer to that before the video started. The real question is the one it leaves hanging in the air as it recedes. When the one that matters finally comes, the one we did not catalog, the one rising out of the glare of the sun, the one that is falling instead of passing, will we be watching? Will we see it in time? And if we do, will seeing it be enough? Tonight, we got lucky. Tonight, the planet killer was just a visitor. The universe will not always be so polite.